All right, welcome everybody. Let's do this. So discontinuities within graphs. We got this. Here, let's talk about three types of discontinuities. A removable discontinuity, a jump discontinuity, and an infinite discontinuity. The idea of being discontinuous is that, let's say if I have my finger on the graph, and that's what I want you to do right now. Put your finger on the graph. If you have to go anywhere on this graph, and the second you have to pick up your finger to go to another part of the graph, this will create some discontinuity because in math we say it's not continuous. Right now, everything is continuous because all the holes are filled in, but right now, here we have this asymptote. So now look, I have to jump with my finger over here. I'm sorry, I have to pick up my finger over here. This creates a discontinuity, and notice at what x value is it? It's at -3, and then here I'm continuous, and I have to pick up my finger, and here is a discontinuity at x equals 1, and then here I keep going, and let's look, when I get to this point, I have to pick up my finger again because I don't have that value. Notice that as I come down from here, the way it should work is, you pick up your finger here, you have to tap your finger over here because it hits that point, and then you go back to the graph over here, and then here's another discontinuity to come here and then finish it off over here. Okay, and now here there are different types of discontinuities that we have to look. Notice that there was a discontinuity here at -3, at 1, and here there's a discontinuity at x equals 4 and at 6. So let's take a look here. At x equals -3, at x equals 1, x equals 4, and x equals 6. Here, the idea is what types of discontinuities happened here. So let's take a look at -3. The pretty straightforward ones are the infinite discontinuities. The second, where your limits are going to positive infinity or even like negative infinity, then we're just creating an infinite discontinuity. And here, these lines that kind of divide, like over here, like these lines over here that kind of like divide this boundary over here, we call these vertical asymptotes. So here, there's a vertical asymptote. So vertical asymptote. There is a vertical asymptote at x equals -3 and at x equals 1. But these are also called the infinite discontinuities. So when we look at our questions here, which x values represent the infinite discontinuities, if any, we could just write x equals -3 and x equals 1. Right? Let's look at x equals 4. Here, when we get to this idea, which picture does it match? Whether it's we know it's not an infinite discontinuity. It's like, which is this one? It's either the removable or the jump. And now here, the best idea to know when it's removable and when it's a jump discontinuity, here for removable discontinuity, notice that the limit exists. And why does it exist? That here, that the limit goes to the same point from the left and from the right. And here, where do these limits go to? They're going to what y value? They're going to L. Whatever L is. L could be any number, any real number, right? Now here, because the limit exists, we're going to call it a removable discontinuity. Because for this one, here the limit exists because from the right side and from the left side, you're going to that same y value. And notice that the limit, as x approaches 4, it's -2. But what's the value of f of 4? It's -1. Okay? So this one here, the removable discontinuity will happen at x equals 4. And when we look at this one, for a jump discontinuity, notice that here, the limit does not exist, right? Because here, my y value coming from the right is different from my y value coming from the left. And that's what needs to happen. That's what happens for when the limit does not exist when they don't go to the same y value from the right and from the left. So we see here at x equals 6, this will be a jump discontinuity, and we could say that at x equals 6, right? Now I hope that really helped, but let's look at the next part. Here, I could feel it right now that some of you are groaning, and you're saying, oh, mister, why do we need to find the domain of the function? Well, we need to get good at this idea. So here, let's take a look at this graph. When we look at the domain of this function, how far left can you go, right? You can go to -9. That's how far to the left. And do you have -9? You do. And notice you just play this game of when does your finger have to come up? So here, from -9, I keep going, I keep going, I keep going, and look, my finger has to come up at x equals -3, so x cannot be -3. There's that discontinuity. So then we say it goes to -3, parentheses, union -3. And then when does it jump again? It's going to have another jump at x equals 1. So here, x cannot be 1, so we say it goes to 1, another parentheses, union parentheses. Oh, sorry, that should be positive 1. 1, right? And then what happens again? Here, do we have x equals, you see here, now x cannot be 1, but do we have x equals 4, right? Now that's a good question. Do we have x equals 4? What is f of 4? Notice that f of 4 is -1, right? Because I say what y value corresponds to it, it's -1. So you do have x equals 4, but at x equals 4, it's discontinuous. Even though you have the value, you have the x value, but it is discontinuous, all right? So here you do have x equals 4, but now we got to keep going, keep going. What about x equals 6? We do have it, and now we could continue that. And oh, it actually just goes to 9. So here, notice that I could just end it at 9 over here, and then bracket, and then close this off. And that's the idea. You have everything. Oh, whoops, sorry. Whoa. Pause. What am I doing? Sorry. It's -9, -3, oh god, what am I doing? Sorry guys. I have it. It's -9, you could have -3, you can't have union, -3, comma, 1, you don't have, parentheses, union, 1, 2, 9. Okay, now that will be it. Sorry. From here, I should have said 1, and then the next union would have been at 9, because you don't have x equals 1, and you don't have x equals -3. So my apologies for that. You see, that's why the domain can be very tricky sometimes, right? Now here for the range, let's look at the range. How far low can you go? How far high can you go? When we talk about how low we can go, what I like to do sometimes is, let me get a ruler. Mr. G's, hold on one second, let me pause the video. Have to look from the bottom to the top. So let's see. What's your lowest y value? Well, let's see. Is it at -infinity? No, because it kind of just stops at -7. So here, notice that at -7, that is your lowest y value. So here, for the range, we're going to put -7. And notice, do you have -7? Yes, it's a filled in hole. Okay, what about here? -6, do you have? Yep, I have a point right there. What about at -5? Do I have a point? Yep, I have a point right here, and I have a point right there. Okay? Let me actually just use a different color. Let me use an orange. So here, you see at -7, I have this point. At -6, I have this point. At -5, I have this point and this point. What about at -4? You have to look left and right. You see, I have this point here and this point here. So it's part of the range. So let's keep going. What about -3? I have this y value, this one, and this one. See, we're going left to right. What about at -2? I have this one, and notice I don't have that one. So I just keep going. What about -1? Yeah, and you keep going, and you keep doing this, and notice that it just goes to positive infinity. And that's the idea for the range, that it goes from all y values from -7 to positive infinity. And that's the range. Right? What I want you to do is try and practice the next one by yourself. And if you want, you could work with somebody in your group. Or what I'll do is I'll show them in class. But you could try and do these by yourself. Okie dokie. Good luck.